always,
So
which always messes up my windows. I never have the live tweet like in a convenient window where I can just pop over and get it really quickly. We are live. Excellent. Thanks for joining us once again. I'm Sammy K. Powers, and this is the PHP Roundtable, which is a live podcast of developers discussing topics that PHP nerds care about. The ultimate goal of this podcast is to learn a little something from each other. If you're listening live and want to be a part of this little shindig, send a tweet to PHP Roundtable, and we'll get your question/snarky comment addressed live on air if we can. A short status update on the elephants. In case you missed the big announcement, listen to episode 72 to learn about the brand new PHP Roundtable Elephant. I mentioned before that the shipping cost to give out these free elephants to PHP user groups around the world was $292.84 USD. There was a lot of people who I sent to who were from like abroad outside of the United States, so that's made the shipping costs really expensive. And I was looking for two sponsors to cover the shipping costs, and Mark Baker got a mad shout out in the last episode as one of the sponsors. So huge shout out to Mark Baker again for sponsoring a big chunk of the shipping costs. And the other sponsor to step up and sponsor the shipping costs that didn't get a shout out in the last one because it hadn't gone through yet, but to get all these free elephants into the hands of user groups around the world is Dark Mira. So a big thanks to Dark Mira for their support. Dark Mira, if you don't know, is an in-house development services company based in Paris, France. And if you can read French, you can visit their website. It's darkmira.fr. But if you can't read French and you speak English only, a lot of us speak English only, you can follow their Twitter handle at darkmira1. So be sure to give a big shout out to Dark Mira and Mark Baker for supporting the user groups around the world by sending some free elephants. Thank you so much. All right, so what are we talking about? Secrets. Shh. Secrets are no fun. All they do is cause so much pain when we're trying to deploy to production. And by secrets, we're talking about database passwords, API keys, any other credentials that you don't want to have landing in the hand of bad actors. There are a number of solutions out there that we want to, or that we implement to keep our secrets out of the code base and in a more secure area, but there are serious trade-offs to the primary solution that the PHP community uses to do this: environment variables. We'll discuss these options that we have for managing secrets and the trade-offs for using them. So now that we know what we're talking about, let's meet our panel. And as always, in no particular order, we'll start off with Chris Cornutt, who is the security engineer at Duo Security and general PHP security advocate. Welcome, Chris.
Hi, thanks for having me.
Absolutely. We also have Nicolas Grekas, or Grekas.
Grekas.
Grekas, awesome. Symphony core team member and involved in organizing the Symphony Conferences and used to be CTO of PHP Blackfire. Welcome, Nicolas.
Thank you. Welcome.
Absolutely. We also have Adam Englander, which I always say Erlander, and we figured out it's because of Erlang. I'm like Adam Erlanger, I guess. He's a software architect for multi-factor authentication products at Iovation. Welcome, Adam.
Thanks for having me.
Absolutely. And finally, we have Scott Arciszewski, who is a security engineer at Paragon, aka Pi. Welcome, Scott.
Happy to be here.
For sure. All right. I just wanted to set the stage a little bit by examining the current PHP zeitgeist, if you will, in terms of how we handle secrets in the PHP community today. So first of all, by secrets, we are talking about those things, as I mentioned earlier, like API keys and things that we don't want any unauthorized agents to possess. And if we are looking at PHP past, these secrets used to kind of exist in config files or like plain old PHP files, JSON files, YAML files, all that. But at any rate, these keys, these secrets existed in plain text right there in the code base, and it was often version control, where basically if you share your code base, everybody who has access to your code base automatically gets access to all those secrets. Not ideal, as this exposes the secrets to way too many eyeballs. So a solution that the PHP community has embraced is basically stealing a page from the Ruby community with a package called .env. .env allows you to add a file to your project called .env, which is ignored by version control and contains all the app's secrets. Then at runtime, it loads all of the secrets into environment variables. So at any time our script needs a secret, it can just pluck it from the environment variable with the getEnv function that we have in PHP. And now we have a code base with no secrets in it, which is a huge win. But the solution is kind of passing the buck to somewhere else. So I wanted to take a look at what specific security issues exist with this widely embraced solution that and what we can do to make things a little bit more secure. So I guess the best place to start this conversation off is examining just that. What are some of these specific security issues surrounding .env to store our secrets? And this is kind of just to anybody.
So one of the major issues is the fact that, because they are sitting there plain text on the file system, if your application has any way to include files from that local file system, local file include vulnerability, all they would have to do is basically pull that file and it would output it to the page. And then they would be able to have direct access to those values, regardless of where it is, if it's accessible from the PHP process, basically. And of course, because of how PHP works, if you're loading things, with the .env library, if you're loading it in there, PHP has to be able to read it. So, it kind of a catch-22 there a little bit.
So there's also.
Go ahead.
Yeah, sorry. There's also the issue that when any error happens, in a sub-process, then maybe not errors actually, but maybe the environment variables are too easily inherited in sub-processes. So sorry for my English first, because I'm from Paris. I do that. So when a sub-process inherits the environment, it gets access to every secret. So that's a big issue because there's a vulnerability that can happen, and then the sub-process can just take those secrets and make anything with them. So that's another issue. And the error one is when some application is misconfigured and the error page just dumps the environment. That's also something that happens, and it's pretty bad when the secrets are there, because like PHP info, there are pages that leak PHP info, so these pages leak the environment. Of course, that end helps a bit, but it's just the beginning. It doesn't close anything really.
Yeah, that's actually another good point. If they can upload code, execute code, arbitrary code injection issues, then they can put their own PHP info function in there and dump all that information. They don't even have to rely on it actually existing. I forget, there was some Google dork a while back that you could use to actually locate PHP info pages on various domains, and there were a surprising number of them out there. I haven't looked in a while, but I remember there being a rather large number of them, unfortunately.
There is another issue that might be relevant too. If you're using a standard LAMP stack, you won't run into this problem. But if you have your .env file in your public web root and you're using a web server app that doesn't block like .files, you might be publicly disclosing your .env file. I used to have this problem when I first got into Nginx. .files weren't blocked at all. So if I upload anything into a .env and you typed, whatever .domain.com/.env, it would just print it out to your screen as a plain text file.
Wow. Wow.
So there's definitely interesting risks that can come in depending on how you store your information, store your secrets. Some of which are really obvious, some of which are, wait, why is that even a problem? Kind of subtle.
So and also bring up that in containerized environments, which I'm most familiar with, especially if you're using something like Heroku or AWS, it's really the only safe way to get things that are going to be environment specific. You're going to pass them through environment variables because that's just the way that they tell you to do them. So the .env file is, yes, sure, it's on a file in the file system, but even if you're doing cloud infrastructure, they're expecting you to use environment files because that's how you're going to deploy it to the different environments and get different values. And that's just kind of what they're expecting as well.
On the whole dumping of the environment variables on debug pages, that's the one that I've kind of run into the most, where I accidentally forget to turn off debugging in production. And of course, it's like you mentioned, it's non-trivial to be able to trigger some of these error messages sometimes, depending on the environment. And then here's all of our secrets exposed to the whole world, which is way worse than just having them in the code base. I feel like, I don't know. But yeah, this is an issue. And by the way, this whole podcast isn't about pooping on the .env project. I feel like that's a really great project that a lot of people are using, and it's widely embraced and things. But I do want to start a conversation about how do we make this more secure. Actually, I was wanting to kind of look at some secure alternatives, but maybe it makes more sense to kind of, if you are using .env, are there certain things that we can do to make it maybe more secure than just kind of maybe the out-of-the-box install and go?
Absolutely, and I'm actually going to point to a blog post that Chris wrote. Basically, storing your .env file information but encrypting it. And the key would live outside of the web root in some specific file, like in /user. I think you'll have the link offhand to that one.
Yeah, the basic idea behind it was that the .env file still sits there on the file system. Everything inside of it is encrypted. The key file, like he's referring to, is often a different directory. It's still potentially accessible by PHP, so if you just use that standard setup, they could potentially read that. The end of the post, however, shows how to use that in combination with Apache environment variables. So basically, the values still sit in the .env file encrypted. The Apache process then is the only one that's able to read the key file. It brings that in as an environment variable, passes it along to PHP, and then the PHP process itself can use that key in the environment to pull that stuff, those values out of the .env file and decrypt them. So you kind of take away one level of it, so that they can't access the key file potentially if there's a local file include. Obviously it's still not perfect, just because of some of the ways that PHP has to read files and read values and having it in the environment, there's all sorts of problems there. But at least it's kind of a step away from just plain text or just encrypted values in the .env. But yeah, I can provide that link.
Yeah, I think it should be worth noting that there's not going to be a perfect solution. If your app needs to be able to decrypt information, anybody who gets, like, let's say remote code execution on your app and can run any arbitrary code as the Apache user, like on a Debian system, there's not much you can do to stop them from doing anything your app's capable of. If you're storing something sensitive like credit card information, you can use public key cryptography to encrypt it so where it can only be decrypted offline, and that will prevent somebody who hacks your app from being able to decrypt past ciphertexts. It won't stop them from substituting the public key with one night control. It all comes down to what is your threat model? What attacks are you trying to protect against? And there won't be a perfect solution, but if you have a realistic threat model, you can build a system that's actually secure against whatever threats you're mostly worried about.
Yeah, there's also a solution that we've used that doesn't work great in a PHP model, but whenever you end up using some sort of secret, you're just removing it afterwards. So in our scenario, like Nginx, when we read up our private key and certificate, after Nginx starts, we delete it from the file system so that only Nginx has access to it. You can do that in containers. You can't necessarily do that on a server. But in the .env world, you might actually be able to, once it's, let's say for Laravel or for Symphony, once it's been read by the container and it's been injected into all the services, it doesn't need to be read from the environment anymore. You can remove it from the environment, so it's no longer available and it won't dump.
Yeah, correct. So that may be obvious, but I just want to be sure to tell that at some point the application must have access to the clear text values, and that's the point. So we're talking only, and that's a big only, about bootstrapping this environment up to the point where the app has access to the clear text values in the secret. So, of course. So I think there's also something which is very important, which is related to the management, the secret management. Who should be able to update a secret value? Who should be able to deploy it? And what are the workflows that allow deploying a new key, allow deploying a key? And I think many issues resolve around that specific issue around workflows, because developers just want to be quick and dirty. So they want to go straight to the point, and security comes after too often. And I think it's very important to try to build solutions and to create solutions that could be as secure as possible without asking people to do crazy things to make it work. So that's what we're trying to do in Symphony. We have an issue right now. And of course, in this issue, we're trying to look at all the solutions that are provided in, let's say, Laravel, because Laravel has some secret management thing embedded, and other PHP and non-PHP technologies. So there are many things to look at around, encrypting the secrets, dealing with asymmetric cryptography, and how to build workflows around that.
Yeah, access was a big issue for us as well. And one of the things that we ended up doing was separating secrets and configuration. Because configuration management, everybody knows what the names of the servers are, those types of things. And especially we use internal deployment with Puppet. There's different ways to store secret data inside of Puppet. And that's what we ended up doing, is separating all of that out. And as developers, we have no idea, have no access to any of the information. It's in a completely separate repository system that kind of gets married as the application is deployed, so that we can limit the access to production secrets as much as possible.
Yeah, you can do something similar with encrypted data bags in Chef. You can actually encrypt the contents. They look like JSON documents basically inside of them. And you encrypt those, and then whenever the deployment actually happens, the Chef process pushes them where they're supposed to be. But nobody has any idea except the people that hold the keys, basically, what's in them.
So we've kind of talked about quite a few solutions here. I'm curious because Nicolas brought up the Symphony issue. I'm looking at the link you sent in the chat here for the PR for the Symphony project. It's 27351. If anybody's listening and wants to take a look at the discussion you're having up there, is this what you're talking about here, something that is used specifically with .env and like a layer on top of that? Or are you looking for a completely different solution to handling secrets in Symphony?
So we're trying to use the environment, not necessarily .env. I mean, .env is one way to feed the environment. And on this specific issue, we're not talking about how the environment is fed, just how we're going to read it from the container point of view. So the container, when it reads the environment, it's able to also access the file system, because we have a concept, we have environment variables processors. So it means that when we take an environment variable, we are able to process it and to transform it step by step. So let's say we have an environment variable that just could be a path to a file. Then we can tell to the container, just open this file. Let's say file get content on this value. And then on the output, let's do some JSON decode. And then on the output of the JSON decode, let's do some GWE decryption, let's say, to make it into a proper value. So we can change that. And we have all the processors except any encrypting one. So that's the issue at glance in this RFC. Well, we're wondering if we should create a processor to decode variables at runtime, basically, coming from the environment, this being a file system or .env or server environments, variables, and things like that. Anything, really.
So it sounds like, go ahead.
Oh, I was just going to say, yeah, it's tricky because in some other, web servers and web application situations, you can actually inject this stuff when the process starts, and then you can get rid of it, like he was mentioning earlier. With PHP, because it restarts and reboots the environment every single time the page is loaded, you can't really do that very easily, because then they have to be someplace. You can't just pass them off and let the process handle it all. So, we have to figure out that compromise. It's not the easiest thing in the world.
Mm-hmm. So reading an encrypted file from the file system looks like the solution we're going to follow. I think at least that's the best of my understanding as something we should do. So the environment would just provide the pointer to the file to read, and then we would open it and decrypt it with some secret and key management solution we have to create.
So how's that going to work with things like Heroku or AWS, where environmentally it's always the same code, or in containers where it's always the same container? I guess in containers you can always, if you really, really wanted to, although it's not a great practice, you could basically link to the file inside the container. But in AWS or Heroku, you don't really get that option.
So I don't know Heroku very well. I know Platform SH and Sensor Cloud, of course. So there's a build step, and in the build step, we don't have the environment variables. We can't compile the container. And then when we deploy the container, it's already dumped as a PHP file, and we just read from the environment at runtime. So this wouldn't change. There's one step we are wondering, and that is discussed in the issue, which is, should we decrypt the secrets at just at deploy time, so that it would be decrypted only once and put in a file somewhere that cannot be included. Let's say we have no include vulnerability, of course. That's another issue. So decrypting at deploy, or decrypting at runtime. That's also possible. So that would be just done at every single request. If it's fast enough, it could be. And if it also helps, the developer experience, we might do that.
As a interesting sidestep to local file inclusion issues, when you're storing files, storing anything in the file system that contains like decrypted plain text, instead of storing that as just like a text file, you could actually make it be like a PHP file that returns an array of strings. Yeah. Then if you have a local file inclusion, it's not going to actually print out anything. It'll just be an array. That doesn't really solve the problem. If you have like local file inclusion, you've got a pretty bad bug on your system. But it's an interesting solution that I've had to deploy a couple times, where we couldn't figure out a good trade-off between different possible threats. So it was, okay, well, the best solution we have is just store in a PHP file and then use the include function and load that in, pass it to an object so it doesn't leak in stack traces, and we're done. But that weird, corner case trade-off solution would actually solve the LFI directly problem.
Yep.
So Pseudo Bang Bang Powers Franzak is behind me yapping. She wants to be part of the conversation. So if you hear, I apologize. It's a little distracting. She's like, I have some answers here. I have some answers here. But I think if we kind of step back a little bit and kind of break this problem down, it just sounds like there's kind of two primary issues here. It's having the secrets encrypted on disk, and then where we store the secrets in runtime. Is that kind of a good way to kind of break it down, like solving two separate problems?
Yeah, I think that's valid.
Yep.
So I'd like to kind of we've kind of been more talking about the encrypted on disk kind of thing, and I'm curious, and I do want to talk about the environment thing too, but I'm curious, like, it seems like some solutions you've been discussing is some of them are symmetric and some of them are asymmetric solutions, and I'm curious, is there a trade-off? I mean, I'm assuming there's trade-offs to everything we do in programming, but is there in this particular situation where we're trying to load from a file, an encrypted file on disk, to choose symmetric versus asymmetric encryption for that?
It really comes down to, for asymmetric encryption, if, let's say, I gave the example of her credit card number earlier. If you wanted to store that to where you could use it for, transactions down the line, but you didn't want you don't need to decrypt it at runtime, you could use asymmetric encryption to store ciphertext, and then somebody in the office would shuttle it over from the database, decrypt it, put it inside their kiosk to, type in a transaction, and that would be the only time they would ever touch it. For most developers, asymmetric encryption is not a solution. It doesn't really work well. If you're adding asymmetric encryption, but your app needs to be able to decrypt it, you're just making everything slower.
Right, and you're also, unless you're using libsodium for asymmetric encryption, you're also restricting yourself to the size of the key with the amount of data that you can encrypt. So If you're using RSA, which is what most people are going to be using for asymmetric encryption, you have to have a key size large enough, and so you're having to make sure that your data is never bigger than the size of your key, which is not necessarily a great option.
So on the other side, about asymmetric encryption, it allows secret management and decoupling. You know, who can update the secret and who can read the secret, depending on how you have access to the public key or not. And it also allows decoupling the management of the private key, which allows decoding the secret. So you can give one single responsibility to the sysadmin guys, telling them, you deal with the private key, and you do it in a secure way. It's your job. You know how to do that. And on the developer side, you tell them just commit the encrypted secrets using this public key, and then it allows kind of better workflows. So of course there are technical issues, but at the workflow level, it enables some things at least people are discussing again in this RFC, and I think that's valid to wonder about.
Yeah, I know Travis lets you store RSA encrypted secrets in your config file and use that on your actual builds as a good example of when you would want to use asymmetric encryption just to make management of secrets easier across like either the public internet or some kind of open network. But I was speaking from the developer's perspective of using asymmetric cryptography to encrypt the secrets themselves, like from your app to somewhere else.
But in our particular situation as well, developers should never have access to the secrets. So it's always good on our side, and every use case is different, but ours is that the system administrators are on both sides. They're the only ones that have access to the secrets. They're the only ones who have access to the private key. So there's not a great trade-off, but I can see in particular scenarios where that might actually be where you have a security group that's going to encrypt the data and a systems administrative group that's going to do something else, but that's not our use case.
So you have it set up like in the Matrix where Neo has to go to the keymaker to decrypt things, right? Sorry, Chris, go ahead.
Oh, it's okay. I was just going to say, in my previous role, one of the projects that I had was to go through the code base and basically take the credentials that they had. We had them encrypted in the, where they were sent along with the code. But what we had to do was take the external services, database or, OAuth to Twitter, that kind of stuff, and basically split them. Because the developers at some point need to be able to test things, and they need to be able to, know what those tokens are for certain things. And so what we ended up doing was splitting off the development applications, like a Twitter application specifically for our development environment, to a production one, so that the secrets management folks had the keys to the kingdom, so, so to speak, for the production ones, but the developers could mess with the dev ones all they wanted to. And it doesn't impact anything because it's not the official production accounts. So that worked pretty well. I know it's a lot of extra work doing the management for that kind of stuff, but it still allowed the developers the information they needed to have, password and OAuth tokens and all that, while not impacting production as much.
And we do the same thing, actually. And for the most part, if it's an external service, which there's very few external services we rely on, we actually just run those containers on the developer's box themselves. So it's their box, they contain it, and so they never have access. It's not even like a development system that someone could accidentally put bad data in or secret data in. It's on your own machine, and you never have access to anything except for the secrets for your own machine.
I do want to make sure we talk about the storing of secrets in the environment variables really quickly, just because I do want to talk about some other solutions that exist out there that are not PHP based. But we have, assuming we have solved the whole encryption on disk issue using symmetric encryption, or our favorite way, and we need to load those secrets at runtime. Right now, we're kind of importing those in the environment variables, and like we said before, if you have a debug message that dumps it all out, that's kind of less than ideal. What are some good ideas to maybe implement or hold the secrets maybe in memory, and maybe use something like libsodium's mem0 when you're done with it, and just kind of clear it out of memory to prevent side channel attacks or whatever. Do you all have any thoughts on runtime secrets?
Yeah. So I'll give a specific example. A couple months ago, we open sourced a library that does searchable encryption called CipherSuite, spelled sweet like candy. And it has this thing called a key provider, which is just like an interface where you can define your own abstract key or your own like backends for key providing. So for example, if you wanted to store your keys in Amazon's key management service, you could just implement the interface, have it pull it from KMS, and load into memory that way. From that point on, it lives inside of an object. It's not a string. You can pass around. You can pass it to what's called an engine, which is basically either libsodium-based or OpenSSL-based. I call that one FIPS mode, and the other one I call NaCl mode for the how it's actually stored as the ciphertext messages. When the object's destructed, it zeroes it out. So if you like use this feature to encrypt like somebody's social security number and I don't know, some other information like their home address if they're a domestic abuse victim, and you want to keep that encrypted because you don't want their stalkers hacking your system and finding out where they live. You could do that, and then when it's done and you destroy the object, it will automatically wipe it from memory using Sodium's mem0. That's the runtime issue. If you're using Amazon key management, that's an alternative to like storing an environment variable. But then you have to make sure you have access to KMS, and that gets a little complicated too, especially if you're using containers. In the test environment, I actually used the PHP file inclusion technique. Just stored in a PHP file, had it do a return string, and that was my key provider. That one's not in the database because that was a specific project.
Yeah, I also wonder, and specifically looking at Nicolas's pull request or RFC for Symphony, if it would be a viable option to, once you have, because you have all these things that says I'm getting this from the environment, and it's specified inside of your bootstrap somewhere in there. If it's possible to just zero that out after you bootstrap it, because it should come back again the next time, right? A request comes in, you're going to get those environment variables again, in theory. So could you just, once you load it up into your container and you've done your dependency injection, can you just zero out the environment variables so they're not accessible, so they can't be leaked, those types of things?
So there's something we can do. We wonder about that. What we can very, very easily do is clear the auto-global variables in PHP, so _server, _env, and so on. To clear the environment, we have the put-env function. And there's a big issue with this one, which is that it's not thread safe. So we do never use it on Windows. And actually, we never use it in Symphony at all because people are running, code on Windows. And then if you run that function on any IIS server, it just breaks. So we cannot clear in a portable way the real environment variables. We can clear the global variables. That's the trade-off. We have to work around that somehow. And based on that, yeah, we should be as clean as possible, as soon as possible.
I'm really interested to see where this conversation goes with what Symphony ends up ultimately deciding on for all these questions. I'm going to run and get my doggie out of the crate because she's going berserko, and hopefully she won't be barking as much right now. So talk amongst yourselves. Rhode Island is neither a road nor an island. No, but I do want you to, if I wanted to, like, as we're wrapping up, it is getting kind of close to wrap up time. Chris Tankersley told me about Vault from HashiCorp, which is a Golang-based secret management type thing. Do any of you have experience with using Vault or other types of, you all have already mentioned like Amazon KMS and stuff like that, for managing your secrets specifically on your PHP projects?
Anyone?
I'm not familiar with their product specifically. However, in the past, we have been approached by people trying to develop something that would very likely be considered competitive to Vault. Those discussions didn't go very far. Otherwise, I wouldn't be able to even talk about them because of NDAs. But they were pretty much in line with what we discussed here, using symmetric encryption. The only difference is that they would either write it to a named pipe, or they'd have some kind of daemon sitting on the system they would request the information from, which isn't great, because if you have a PHP install that like blocks anything that can spawn a shell, like shell exec or any other kind of arbitrary command line executing function, you couldn't use it. So they were trying to find creative ways to work around that. And yeah, I can't speak to the implementation of Vault, but the general genre they're in is, if it's not what we're already discussing, it rhymes with it.
Yeah, using an external service like that has one other major benefit that I've seen. It allows you to configure either access policies or specific users and what they have access to, and it also lets you specify where they can be requested from. So if you have the keys for the Vault connection in your production server, well, if those keys get compromised and they get taken, then it's really difficult for an attacker in a different location that's not your server to be able to use those keys to access Vault. Now, ideally, obviously, you're going to have that internal to your network, but still, they still would have to stage an attack from that specific source with that specific user. And if it's a read-only user, then they can't update the data; they can just read it. So it just depends. It gives you a little bit more control, more flexibility. I know KMS lets you do that kind of stuff with the policies on there as well. So it's a nice benefit to have with that external service. Unfortunately, you have that extra hop basically to go get the credential information. But like Scott was saying, it depends on your threat model and everything.
An additional benefit, if you decide to use a service like this, is that a lot of them offer auditability. For example, cryptographically assured access logs. That's actually one of the things that a lot of people approach us about, because we have a thing called Chronicle. It's a microservice that kind of solves a lot of the problems people reach for blockchains to solve, but isn't a blockchain. It's just a hash chain data structure. So we frequently get asked, hey, do you think this would be a good solution for, SIEM integration? I know that KMS definitely has like auditable logs from any accesses to your encryption keys. Most of the other products in this sector should offer the same, and if they don't, it might be an enterprise-only option. But it's definitely something that it should be on their radar if they're seriously trying to compete with like Vault or KMS or any other secret management products.
One of the things I'd like to bring up before we actually end all this is that we talk about a lot of really kind of esoteric and super awesome secure solutions, but it's also important to remember that if you're doing something really terrible, doing something less terrible is always better. So if you're committing all of your configs into your code and you're determining based on an environment variable which one of those to look up, which is I've had systems like that where you've got a prod config in your code, and a Darcy config in your code, and a dev config in your code. Removing that out and using something like .env is a giant sleep up for not leaking your production keys and things like that. So if you're listening and you're thinking, oh, wow, this is so complicated, I can't figure all this out, and like .env isn't perfect. Well, .env isn't perfect, but it's way better than having credentials in your code. And there are, take some steps to make it better. And then once you get it better and it's a reasonably livable solution, then work to make it awesome. But just don't leave it terrible because you're like, this is too much. I can't think. I can't do anything. It's so overwhelming. I don't even want to get started.
Yeah, definitely. Half of the time, especially with legacy applications, incremental improvement is definitely the way to go. There's no reason to just dive straight into the code base and say, oh, I'm going to implement all new security controls because, on this podcast, they said I needed to do this and all this. It's like, no, just take those small steps and, reduce the risk. That's basically what it's all about.
Yeah, unless your threat model includes the NSA and the KGB, you probably don't need to go overboard. .env will probably solve the 90% problem. Following Chris's blog post and encrypting it, and using Apache environment variables will probably solve the other 5%. And then if you're in that 5% left that needs a hyper-paranoid threat model, definitely get cryptographers and security experts on board to help you solve it, because a lot of these decisions will be driven by business goals, by technical debt, environment constraints. If you're all on AWS, then using Amazon KMS and making it not your problem is probably the easiest solution. But if you're on like a bunch of VPSs scattered across the globe and you're doing some kind of horizontal scaling infrastructure on multiple cloud providers, you might have different challenges. Or if you're all on one dedicated server somewhere in Colorado, even how you host your application will matter a lot.
This is some great stuff. Pseudo is joining us now because the only way I can get her to not bark is to hold her. So she's a little squirmy right now. I'm also getting well actually'd by Colin Odell on Twitter. And he says, fun fact, Rhode Island is actually an island. And he's got a link here to prove it, apparently, on the internet. There's always proof on the internet. So thanks, Colin. I appreciate the fun fact. As we kind of wrap this up, I wanted to, I guess my ultimate goal for this episode is to kind of maybe spark a bigger conversation. And it sounds like it's already been going on in the Symphony community and a couple of others, to maybe by this time next year, we'll see a big shift in the way that we handle secrets in PHP. And as you all said already, getting off of your config files and storing your secrets in config files and getting on .env is a really good step forward. So hopefully by the end of this podcast, you're not feeling bad because of the way you're handling secrets, but you're being encouraged to be like, okay, one step at a time, we'll make this a little better each time. You know what? We actually have a developer shout out because we gotta wrap this thing up. And I want to make sure we have some time for the developer shout out, which is something, a segment that we haven't done in a really long time. And it's my favorite segment because it recognizes a developer in the community for being super awesome. And the PHP Roundtable sends the developer a handwritten thank you card, a little sticker, and a gift as a thank you for their contributions. In past episodes, we've been sending out gift cards, and we've sent over $2,400 of gift cards so far to developers around the world, which is really cool. And this is a really great gift, but starting today, instead of sending a boring old gift card, I wanted to start sending out something a bit more meaningful. Can you guess what it is? The new developer shout out gift will be the brand new, extremely rare PHP Roundtable elephant. So people are climbing over tables to get this thing, to get one of these elephants. So I can't think of a better way to say thank you to an awesome person in the community than to send them one of these rare elephants. So sponsoring this episode's developer shout out is Southeast PHP. Southeast PHP, which runs August 16th and 17th, is a community-run conference that is bringing the best and brightest of our community to the South for a weekend full of great talks, friendship, food, and music. Tickets are now on sale at southeastphp.com/tickets. Now, for this episode, I asked the panel to nominate a developer to receive all the glory of the developer shoutout, and the panel nominated Jordan Hall. Yay! So, Chris, why did y'all nominate Jordan Hall?
Well, Jordan is developer of a PHP package called the password exposed. It's a helper function, basically, that goes along with the rest of the password functionality that's in PHP now. And what it does is it makes a request against an API. There's a site that's called Have I Been Pwned? And basically what it does, that site, is it gathers all of these password dumps that have happened over time, and it stores them. And basically what this package does is it lets you query that API. It queries against this huge password store that they have on that side, and lets you know yes or no as to whether it's been exposed or not. It's just kind of a good way, a super simple way, really, to drop into your application and make sure that people are actually using strong passwords and unique passwords. So I would highly recommend, if you haven't checked it out yet, go and take a look at it. There's lots of other packages for other languages as well that do the same kind of thing. But this is really the first good one that I've seen for PHP. So just wanted to make the recommendation for Jordan there.
That sounds like an amazing package. I've got to check that out and add it to my next project because holy crap, that's going to add a lot of security sounds like to just when people create accounts and stuff. That's great. So Jordan, I'll be reaching out to you soon to get your snail mail address to be sending you this epic thank you package on behalf of me and the panelist guests, and of course, Southeast PHP. Thanks again, Jordan, for your contributions. And thank you, Southeast PHP, for the sponsorship of the developer shoutout segment. And I think it's officially about time for Pseudo to squirm out of here. But before we do that, let's hit up some shameless plugs. Let's start off with Chris. Do you have anything that you would like to shamelessly promote?
Yeah, the website that I write security articles for, a lot of them are PHP specific. It's the site that Scott had mentioned the article on, websec.io. I post articles out there every once in a while, but hopefully some of it's useful, more specifically to PHP developers.
Awesome. What about you, Adam? Do you have anything you want to promote?
I have nothing to plug except for go see websec.io.
Thank you.
Nice. What about you, Nicholas?
Oh, yes, I have. We are running the Symphony Conferences, and we're on live.symphony.com. The call for paper for Symphony Live USA, which is in San Francisco in October. We also have SymphonyCon Lisbon coming, and Symphony Live London, and Symphony Live Berlin. So if you're up to attending or just speaking there, you're welcome, and more than welcome.
Excellent. Finally, Scott, you have anything you want to promote?
Actually, no. Websec.io actually has a lot of good stuff on it. I recommend people read it. I have a lot of open source libraries, the Paragon IE organization on GitHub that I don't promote enough, but I can't think of which one is relevant here more than the others.
Cool. Awesome. Well, as we kind of wrap up here, I hope you'll join us in the next episode. There's a couple of them, actually quite a few of them on schedule. Whoa. Pseudo's getting really squirmy here. One of the next episodes is the Web Content Accessibility Guidelines 2.1, WCAG, I think is how you say it. So it'd be really interesting to take a look at that. We're also a little late to the party here, but GDPR for PHP developers, it still affects us today, so might as well talk about it. Also, all things Drupal. We've done a lot of all things WordPress, all things Zend, all things Laravel. Let's do all things Drupal. Let's do another one of these big projects and talk about it. And if you have something you'd like to share on the PHP Roundtable, say you have a topic that you'd like to hear or like to join the panel, go to phproundtable.com and fill out the little form that says, I want to join the roundtable, or ping me on Twitter. I'm Sammy K, or PHP Roundtable on Twitter. And with this is the time we have to wrap up. I'd like to thank Adam, Chris, and Nicholas and Scott for joining us in this discussion, and we'll see you folks in the next episode. Bye. Say bye, Pseudo.